Describe the surface with the following parametric description. So the first thing I'm going to do here is identify the x, y, and z components for the given vector valued function in terms of u and v. So looking at this two-parameter description, we can see that x here is defined as v. We can see that y here is defined as 6 cosine of u. And we can see that z is defined as 6 sine of u. So now comes the tricky part. We need to identify a relationship amongst these three components. So there's not one method that we can use, but something that you may find helpful is to go ahead and square each component, keeping your quadratic surfaces in mind, and look for or identify a relationship amongst them. So we are going to square each component in hopes of identifying a relationship amongst the variables. So here we go. Squaring the x component gives us x squared is equal to v squared. Squaring the y component, we see that y squared is equal to 36 times cosine of u squared. And then squaring the z component, we see that z squared is equal to 36 times sine of u squared. And we can see here that the y and z variables have something in common. They have 36 in common. So let's now go ahead and try adding those two variables together and see if we can identify a bigger picture. So we have y squared plus z squared is equal to 36 times cosine of u squared plus 36 times sine of u squared. And again, we see that greatest common factor here of 36, so let's factor it out, which gives us 36 multiplied by cosine of u squared plus sine of u squared. And we're getting really excited here because we see there's Pythagorean's identity, which we know is equal to 1. So what this is leaving us with is that y squared plus z squared is equal to 36. And we recognize this as a quadratic surface. Thinking back to our quadratic surfaces, when you have a three-dimensional surface defined by only two variables, we know that it represents a cylinder in R3. And since the x variable is missing from this equation, we know that this cylinder in 3 dimensions is centered about the x-axis. And since this is equal to 36, or 6 squared, we know that this cylinder has a radius of r equals 6. So the only thing left is we don't want to forget about v. So thinking back to our x component here, and looking up at what's given, notice that v has the bounds. So we can now make one more little note here and say that since v is greater than or equal to 0, less than or equal to 2, or in other words, where x is greater than or equal to 0, less than or equal to 2, this lets us know that the cylinder is bounded by two planes. So the cylinder is bounded by the planes where x is equal to 0, or in other words, it's bounded below by the yz plane, and bounded above by the plane x is equal to 2. So this also lets us know, we can add here, that the height of this cylinder is 2 units. So you can say that h is equal to 2. Woohoo! And we have officially classified the surface for this parametric representation.